Hi guys, we are working right now on Math Lesson 8.3. Math Lesson 8.3, you will need your student workbooks, and we're going to be on page 321. We'll get there in just a minute. But let's start. Today we're discussing perimeter and area. Perimeter and area. I'm going to grab my manual today because I'm going to need this as we go through our video. Well, we'll see how it goes today. Okay, so let's take a look. Ooh, I do have a new whiteboard. I hope this works out. You guys are going to be kind of my experiment for the day, so we'll see how this works out. I'm going to draw a little rectangle here. All right, so this side is 3 centimeters. Up here is 5 centimeters. Okay, and if I asked you to find the perimeter of this, do you remember how to do that from 4th grade? Yeah, I hope so. To find the perimeter, it means that we are looking for the whole outside measurement of this rectangle. All of the outside. So here's an outside measurement. I have 3 centimeters. Here's an outside measurement, which is 5 centimeters. Okay? These two are blank, but I can figure them out really easily. So if I'm looking, this measurement right here is 3, and this side right here also has to be 3 centimeters. Okay, these two sides have to be equal in order to make a rectangle. And if this measurement up here is 5 centimeters, then this measurement right down here also has to be 5 centimeters. Okay, so when I find the perimeter, I'm going to add up all of the outside measurements. Okay, but another way that we could do it, I'm going to erase these right here. Another way that we could show that, if we had a formula for perimeter, it would look like this. 2 times the, I'm going to do a cursive L for today, because they have it as just a line, a lowercase l, and that is really hard to remember. I'm going to do a cursive L. So 2 times the length plus 2 times the width, and that equals the perimeter. So 2 times the length would be 2 times 3 plus 2 times the width, which would be 2 times 5, and that would equal our perimeter. Let's make sure that we're right here. I'm going to put these measurements back up, and let's add them up as we go, okay? I've got 5 plus 5 is 10, 3 plus 3 is 6, 10 plus 6 is 16, so we're going to say that our perimeter equals 16. Well, let's check this formula that we just made here and decide if we're right. So 2 times 3 is 6, that's 2 times the length, right? Plus 2 times 5, which is 2 times the width, and that's 10, and that equals the perimeter. 6 plus 10 is 16, so our perimeter is 16. So we can use this formula, 2L plus 2W, 2 times the length plus 2 times the width equals our perimeter. And we're going to use that today, so hang on to that knowledge. Okay, now, well, let's go back to our little shape here. This side is 3 centimeters, so actually I'm going to divide that up. So I've got 3 centimeters long. Each of these little sections would be 1 centimeter. 1, 2, 3. And if this one's 5 centimeters, I'm going to divide that up into 5 centimeters. I'm not exactly even, but that's okay today. 1, 2, 3, 4, 5 centimeters. Okay, so now this actually will help us find our area. We want to find the area of this square, rectangle. Sorry, it is a rectangle. I could count up. Let me back up a tiny bit. If we remember right, we've talked about area already this year, but let's go ahead and look back at it. Area is the measurement of all of the inside of the shape. Now, perimeter was the outside edges. The area is how much space is taken up inside our shape. So now back to where we were, I could add up all of these little squares, couldn't I? Because each one is 1 centimeter. Because I've got 3 centimeters here, I've got 5 centimeters there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So my area equals 15 centimeters. Is there an easier way to do that than adding up all the squares? Absolutely. We already know. We know the formula for area, don't we? Shout it out. I know you know it. Area equals length times width. You're right. So I'm going to find my length, which is 3. So area equals 3 centimeters times my width, which is 5. 3 times 5. 3 times 5 is 15. So our area equals 15 centimeters, which is the same as what we did when we counted, right? Yeah, we got the same. All right, perfect. So we are at a really good start. That light is like blinding, isn't it? Let's just see how we can, now it's really dark. I can't win. I have bought a lamp to put in the front to give us some more light, but hopefully it'll be here soon, and we'll just have to deal with the glaring lights for now, and our lamp will be here soon. Okay, so we've got the difference between perimeter and area. What I'd like you to do is turn to page 321 in your workbooks. 321. Okay, so it gives us a definition of perimeter and area at the top. Perimeter says, perimeter is the distance around a figure. Area is the total number of unit squares that cover a figure. So it's kind of that whole inside, right? A unit square has an area of 1 square unit. We were working with centimeters before, and that's, looks like this whole page is in centimeters, so that's going to be our square unit for today. Okay, so we showed some examples of this first part already. Rectangle A talks about what is the formula. Can you think back to what we just discussed? What's our formula for the perimeter? Do you remember? 2 times the length plus 2 times the width equals P for perimeter. Or you can switch it if you started writing it like this, P equals 2 times length plus 2 times width. You could write it like that with the P and the variable at the beginning, which is probably actually the proper way to write it. Okay. Next, it asks for the formula for the area. We just talked about that. Write the area formula on that line. You know it. Area equals length times width. There we go. Okay, now the bottom half of our page in our workbook talks about fractional side lengths. So it's talking about finding perimeter and area with fractions. Dun, dun, dun. We can do this. We can do fractions. So let's look at rectangle C. Rectangle C. We're concentrating on area right now, not perimeter, but it talks about finding the area. Let's see, it's just giving us some examples. If we were to find the area of just that little green rectangle, remember our area is length times width, so to find the area of that little green rectangle, we would do 1/3 centimeters times 1/5 centimeters. Remember, when we multiply fractions, we multiply straight across. We do not need to find a common denominator, and we do not do keep, change, flip, because that's division, right? So multiplication, this is the easiest one. We just multiply straight across. So 1 times 1 is 1. 3 times 5 is 15. Okay, so, and this is, it's square centimeters. We're finding that unit square. I put a square at the end like that little 2 at the end means squared. In our book, it just says, it does it like this, square centimeters. And today, either way is just fine. Also, if you're looking at the square, if you count the total number of squares in this shape, it would be 15, right? It's what we were working with before. We have 1, 2, 3 times 1, 2, 3, 4, 5. There's 15 squares. So this little tiny green square is 1 out of 15, or 1 of 15. And as a fraction, sorry, I was cutting there. Let's try again. As a fraction, 1 of 15 looks like 1 over 15, right? Okay. Okay. The same with rectangle D, if you take a look. So we are going back to that first rectangle that we started with that has 3 down and 5 across, right? It has a total number of unit squares of 15, but now it's wanting us to find the area of just the green part. Just the green part. And I'm just going to help us out a little bit here. So okay, so here we go. And so remember, this is how are we going? The total over here was 3 centimeters. So if we're just looking at this section, this is 2 of the 3. And this was 4 of the 5 centimeters. Okay, I know my drawing is not the best here. But let's go back and let's answer number 1. So we're gonna answer number 1 here. It's actually, I'm gonna erase that because I don't want to confuse you with this question. We're looking at the first example right here, okay, and then we're gonna answer question 1 right here. It says, find the perimeter of each green rectangle shown above. Okay, express your answer as a mixed number. Now we're actually getting to perimeter. And our little tiny green rectangle above in that example, the measurement on this side is 1/3, and the measurement on this side is 1/5. And they want us to find the perimeter. Okay, well, if we remember back, perimeter equals 2 times the length plus 2 times the width, right? Okay, well, our length is 1/3, so let's finish out and plug these numbers into our formula and we'll find the perimeter. 2 times the length would be 2 times 1/3. Okay, our length's right here and it's 1/3 plus 2 times the width. And our width is right up here, it's 1/5. Okay, are you with me? So we can do this. Let's figure it out. Let's figure out 2 times 1/3. So I would make him be a fraction, which I do 2/1 times 1/3, which I keep, and I just multiply straight across. 2 times 1 is 2. 1 times 3 is 3. So 2 times 1/3 is 2/3. Okay, so I'm going to take that and I'm going to put it right underneath right here. Okay, that's my first part right here. So P equals 2/3 plus 2 times 1/5. All right, let's try that one. So I got to turn 2 into a fraction so I can multiply straight across, and any whole number is a fraction. It has an invisible 1 underneath it. We're going to write it out. So we've got 2/1 times 1/5. So times 1/5. Oops, let me write that a little bit better. Multiply straight across. 2 times 1 is 2. 1 times 5 is 5. Okay, so 2 times 1/5 is 2/5. So I'm going to erase that so I can just write 2/5. Okay, so our perimeter equals 2/3 plus 2/5. Now, we are adding fractions. We've got to remember back to our rules about adding fractions. I told you before that multiplying fractions is the easiest thing. Adding fractions is pretty easy too, but we can only add them if we have a common denominator. So let's think about that for a minute. Our denominators right now are 3 and 5. What's a common denominator we can give them? It's a number that 3 and 5 both go into. Or we can times these together and use that. Let's do that. 3 times 5 is 15. So let's make 15 be our common denominator. I'm going to write that right underneath. Okay, let's go back. This is a little bit of a review. We haven't done this for a while, right? So to get from 3 to 15, I times by 5, right? 3 times 5 equals 15. So I'm going to do the same to the top. 2 times 5 is 10. Okay, that's my new fraction. 2/3 equals 10/15. And we just need this one for the common denominator. Let's do the same thing over here. 5 times what is 15? How do I get from 5 to 15? Multiply by 3. So 5 times 3 is 15. Now I got to do the same to the top. 2 times 3 is 6. There we go. Now we can add these together, right? We're going to keep our same denominator, right? And then we add the numerators. 10 plus 6 is 16. So our answer is 16/15. Are we done? No, we can't end with an improper fraction. We cannot do it. Nope. We've got to simplify this a little bit or change it to a mixed number. There we go. Okay, so 15 goes into 16 one time, right? With how many left over? 1 times 15 is 15. 16 minus 15 is 1, so there's only 1 left over. And we keep our same denominator. Can you guys see that? 1 and 15 centimeters. Okay, so we found our little perimeter for that tiny little green rectangle. It took us a minute, but it wasn't hard. This is all math that we've already done before, right? So it's remembering the rules again, but we've done it. So that was easy peasy. So number 1, rectangle C is 1 1/15 centimeters. Write that in for number 1. I do not like this. Being on camera is not my favorite thing. Okay. That's okay. I need to embrace it. I need to love it. Maybe one day I'll get used to it. Okay, let's do the same with rectangle D. Now this is when I would have you do it with your group. You would work on it with your group, but unfortunately we can't do that, so we're going to work on it together. Okay, so we are looking at rectangle D and we're going to find the perimeter. Now, if it's the green part, it's the green part on rectangle D. So I've only have written the green part. Don't worry about the rest because that's all we're trying to find right now. Okay, so this is my little representation of the green part. If we were finding the area, we would do 2/3 times 4/5, right? That would be easy. If we were finding the area of this, we would do, the length times the width, and we would multiply those straight across, so we would get 8/15. We could also count 1, 2, 3, 4, 5, 6, 7, 8. There's 8, and in the total shape there was 15 squares. So that's how we find the area. But we're finding the perimeter. Let's remember what our formula for perimeter is. It's 2 times the length, because remember, here's a length right here, here's a length right here, and 2 times the width. Here's a width up here, and here's a width down here. And then if we add all those together, boom, 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 that's how we get our outside measurement, or our perimeter. Okay, so no problem, we've got this. Perimeter equals 2 times the length, and our length is listed right here as 2/3. So we got to do 2 times 2/3 plus 2 times the width, and our width is right up here, which is 4/5. Okay? I want you guys to write this along with me. I think that might help you. So write it on the side of your workbook, but stick with me, write it out, because I think it will be very helpful. Okie dokie. So now we've got to do some multiplication, right? We have 2 times 2/3 and we have 2 times 4/5. Let's figure those out right now before we can add together, correct? Okay. Okay, so we've got 2 times 2/3. I'm going to turn that one into a fraction, 2/1, so that I can multiply. Okay, we multiply straight across. 2 times 2 is 4. 1 times 3 is 3. Okay. You know what? I'm going to leave it right now as an improper fraction because I'm going to have to add it to something else in just a minute. So for now, I'm going to leave it as an improper fraction. Okay, so 2 times 2/3 is 4/3. So let's just bring the rest of our equation down. Okay, so we've got 4/3. Now we got to do this one. 2 times 4/5. All right, let's write it out. 2/1 times 4/5. Okay, we're going to multiply straight across. 2 times 4 is 8. 1 times 5 is 5. So we've got 8/5. And again, I'm going to leave it like that just because I'm going to have to add these up, and I've got to find a common denominator anyway, and I would have to go back to an improper fraction. So I'm going to leave it right there at 8/5. So we got 8/5 for that. 2 times 4/5 is 8/5. Okay, so now we're back to an addition problem for fractions to finish off our perimeter here. Okay, so we have 4/3 plus 8/5. What should be our common denominator? That's the same as last time, right? Because we had a 3 and a 5 last time. And if you were looking at our big picture, there's 15 squares, so it makes sense for it to be 15 anyway. So our common denominator is going to be 15. No problem. Okay, so we went from 3 to 15 by timesing by 5, right? 3 times 5 is 15, so let's do the same to the top. 4 times 5 is 20. And that makes sense because my numerator was larger than my denominator in this one, and so we have 20 15, so it's okay, that's fine, we're good. Okay, let's do the same with this one. 5 times what equals 15? Times 3, you're right. So 8 times 3 is 24. There we go. Okay, so right now, we've got our common denominator, which is 15. Our denominator stays the same. We're just going to add our numerators. We have 20 plus 24. 44. 44. Okay, well, we can't leave it like that now. Now we're at the very end, so we've got to turn it into a mixed number. How many times does 15 go into 44? It was so close, man. 15 does go evenly into 45, so we were super close. It goes into 45 3 times, but we're not quite to 45. We're just at 44, so it's going to be 2. It's going to go in 2 times, okay? That's our whole number. Oops, you can't see that. What? Oh, that makes it worse. Okay, so P equals 2. It goes in 2 times, 2 whole times. 15 times 2 is 30. Okay, we have 44 though, so what's left over? 14. 14. And we keep our same denominator, which is 15. So our perimeter for this green part of rectangle D is 2 and 14/15 centimeters. Okay. All right. It is kind of a lot of work, but it's all stuff that we've done, so it's not too bad. We can do this. Okay. Now flip your page over to 322. Let's talk a little bit about that. And I will try to finish up pretty quickly here. 4 says to shade and label the model below to show the area of a half millimeter by, nope, that's not a millimeter. Half millimeter would be mm. What am I looking at? Mile? Mile, it's a mile. Good night. Okay, that's okay. I guess when I think of a mile, I think of a bigger space, but it would work if this was a map or something, so I'm sorry if I confused you. Okay, so we're looking at this and we want to show a half mile by a quarter mile. And our shape looks like this. Okay, and so let's see. This is 1 mile. And this is 1, not a half a mile. This is 1 mile. Okay. Now, if I were to show an area or a part of this shape of a half by a fourth, we could do that really easily. In fact, if I look at the half is 1, and one way that I say this, depending on the situation, I say 1 out of 2, or 1 of 2 wholes, right? 1 of 2. So if I look at this side, this is where I have 2, and it's going to be 1 of 2 when I'm looking at it from this direction, right? Here's 2, that would be my denominator because it's out of 2 wholes, and I'm only going to color in 1 of them, okay? But now if I was looking at it from this direction, this would be where my 1/4 comes in, because look right here, I've got 1, 2, 3, 4 parts, and I'm only going to color in 1 of the 4 parts. So this is my 1/4, and this is my 1/2. Okay? So if I were to shade in an area of 1/2 mile by 1/4 mile from this larger shape, this is what it would look like. Okay? So if you have to do that, in fact, let's try that on the next one. I'm going to have you color it in. So look at number 5. Shade the model to show the area. I'm going to just make my, I don't want to have to rewrite the whole thing. Oops, I can keep that. Okay. Okay. Sorry, number 5. Shade the model to show the area of a 1/2 mile by 3/4 mile rectangle. Describe what your model shows. Okay, so go back to what we were talking about before. Let's show the area of the 1/2 mile. So it's going to be 1 of 2 holes. So we've got to look at the part where I see 2 holes. That's going to be me looking at it this way because I've got 1, 2. So we're going to color in 1 of those. So this is the 1/2. Okay? Now the next part says by 3/4. That means times 3/4. And we need to look at it the other way now. We're going to look at it from this direction because it means 3 out of the 4. So 4 total parts is going to be looking at it from this direction. 1, 2, 3, 4 across, right? So it says now, though, that we are going to shade 3 of the 4. Last time it was just 1/4, which would be right here, right? But this is 1/4, this is 1/4, this is 1/4, and this is 1/4. We need to color in 3 of those. So we're going to do another, which would be 2/4, and another, there we go, would be 3/4. So when we shade the model to show an area of a 1/2 mile by, I'll take those off and just summarize it into 3/4 mile, that's how we would do it. Okay? Whew, all right. The next part is practicing with area. Let's just look at number 7 together. We'll just get you going really good, and then I'll tell you what the numbers are for your homework. We'll be done, okay? So look at page 323. Okay, I'm kind of loving this whiteboard. It makes it so much easier. Okay, number 7. We're going to find perimeter and area. Each side on this little shape is 1/2 of a centimeter. I'm not going to write my label right now because we're just going to try to hurry. Okay, so to find my perimeter, we can either add up each side, right? I can go 1/2, 1/2, 1/2, 1/2, and I can add them all up. Well, 1/2 plus 1/2 is 1 hole. Another 1/2 plus 1/2 is 2 holes. So the perimeter would be 2 centimeters. But I can also use our formula, and this is probably the preferred way because this will help us in other cases. We won't always have numbers this easy, right? Our preferred way is to say that perimeter equals 2 times the length plus 2 times the width, okay? So we've got 2 times 1/2 plus 2 times 1/2. Here's our length, here's our width. Okay, 2 times 1/2 equals 1 hole, plus another 2 times 1/2 equals 1 hole. So our perimeter equals 1 plus 1, so we've got 2 centimeters. Awesome. That's what we said before, right? We got it? Was that kind of fast? I hope I didn't go way too fast for you. Okay. Remember, you can always pause the video. If you need to pause or rewind, you can always do that. Okay, now let's do the area. So I'm going to keep my shape up here. Remember that area equals length times width. Okay, so we're going to do the length times the width right here. So area equals 1/2 times 1/2. And I can do that by just multiplying straight across. 1 times 1 is 1. 2 times 2 is 4. So my area is 1/4 centimeters. And remember, this is square units. So we're going to say 1/4 square centimeters. Okie dokie. That's your area. Okay, one last thing that I want to cover is finding the side length of something when we know the area, but we don't know all the length of the sides. So look down at number 11. Okay, so number 11, we have kind of a bigger rectangle, right? It gives us one side, which is 4.8 meters. This side we don't know. And then it gives us the total area. So area equals 29.76 square meters. There we go. Okay, I know. Ooh, I hope this is big enough that you can see. All right. Well, I know that area equals length times width. I'm going to fill in my numbers here really quick here. I do know my area, so I'm going to put that in for A. So I've got 29.76, so 29 and 76 hundredths equals the length, which is right here, 4.8, times the width. Now, the width is what I don't know, so I'm going to keep it as a W. Think about this for a minute. Usually we do length times width equals area. I already know the area, and I know one side, but I don't know the other side. What am I going to do? We kind of have to work a little backwards, right? We're going to use some fact family information like we did before. Something times something equals this, but if I go backwards, I could divide. I could take my total, divide it by what I do know, and that will give me what I don't know. So I'm going to divide. We're going to do 29.76 divided by 4.8. Ooh, we've got a little bit of some review in this lesson, like all over the place. It's awesome. So let's divide with decimals. Now my first step is, remember, I have to have a whole number to divide by. So I've got to move my decimal over 1 to make this be 48. I don't want to divide by 4.8, 4 8 tenths. I've got to have a whole number. So I move it over 1. If I move it over 1 here, I have to move it over 1 here. So I'm going to take this, I'm going to move it over 1. So my decimal is going to be right there. It's going to be 297.6. okay? And that's where my decimal is going to go. So my next thought is, okay, how many times does 48 go into 2? Well, that's too small. That's not going to work. How many times does 48 go into 29? Still too high. That's not going to work. How many times does 48 go into 297? This is when I'm going to kind of round, and I'm going to say, okay, this is close to 50. And this is really close to 300. How many times does 50 go into 300? I'm going to take off a 0 on each side. How many times does 5 go into 30? 6 times. Am I close so that we can get this done fast? Oh, I don't know. Let's try it. Let's just try 6. Let's try 6. Okay, now we have to do a little bit of work here. We actually now have to do the actual multiplication. I can't just round. So I'm going to do 6 times 48. 6 times 8 is 48. Carry that 4. 6 times 4 is 24. Plus 4 is 28. So, good. I was close. Yeah, let's do 288 right here. We're going to subtract. 6 times 48 is 288. Now we subtract. Subtract and bring down. Dun, 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 dun. Natalia wants me to play the song. I know it. Maybe I will. I'll play it for you guys later. Okay, we can't do 7 minus 8, so I'm going to borrow 1 from the tens place. Make that an 8. 17 minus 8 is 9. And then 8 minus 8 is 0. 2 minus 2 is 0, so I have 9. Okay, now I got to bring down. This was my subtract. This is my bring down. Subtract and bring down. Okay, here we go. 6. How many times does 48 go into 96? Actually, 2 times. 2 times 48 is exactly 96, so my 2 is going to go right there. 2 times 48 is 96, and 96 minus 96 is 0, so we are good. So my other side, yes, we are good to go. My other side right here is 6 2/10 of a meter. There we go. So if I don't know a side, I'm going to divide. I'm going to use my total area that I know, and I'll divide by the other side that I know, and it will give me what I don't know. Okay? Ooh, lots of review today. You guys are amazing. If you stuck through this whole video, then you are going to luck out because I'm going to tell you what you need to do on your homework. So we're doing 8-3 homework, okay? I would like you to do, I do want you to practice a little bit. We didn't practice very much in our book, and I'm sorry this teaching video is long, but I want you to do 1 through 6. How about 1 through 7? You don't have to do number 8. Let's do this. Okay, hang on. I'm going to circle the ones you have to do. I want you to do 1, 2, 4, 6, 7. There you go. 1, 2, 4, 6, 7. 1, 2, 4, 6, 7. 1, 2, 4, 6, 7. That's all you need to do because you watched the whole video and you're amazing and I love you and good luck. I think you guys will be just fine with this, but if you do have questions or comments, let me know, and we'll have a Zoom on Wednesday morning at 10 o'clock. So you can also ask questions there. Have a good day.